Hey boys and girls, welcome back. We've got another video for you. Today I'm going to be doing something a little bit different. So I'm going to show you the next step in the process, for me anyway, is a coolant reroute. And this is a good idea to do a coolant reroute when you're going to be adding forced induction, but it's not really a requirement, but in my case it kind of is. And that's because of the way I'm doing it. So I'm going to get into this, but before I get started, I want to ask you to take a look at this idea and tell me what you think, because I haven't really seen it done this exact way before out there. So tell me what you think, and I'll tell you what I have in mind. Let's see what it looks like. So I think it'll first be helpful to understand what a reroute is and why you would want to do it. Now this has been covered a lot in the Miata community, but just to give you a quick run through, let's take a look at this diagram. Okay, so the engine was originally in the Miata mounted transversely, and so what that meant, it was for a front wheel drive car, and as you would expect, the coolant went in the front and it came out the back, and both the front, what is now the front and is now the back, was on either side, and both were easily accessible. When they mounted it in the Miata to make it a rear wheel drive car, the back is irritatingly close to the firewall and it's very difficult to access. Now, where the coolant exits the block is where you want to have your thermostat. And a thermostat replacement is a very common maintenance item. And so that's not really something that you want to have hidden in the back. Everybody's going to hate you for that. So the engineers decided to change up the way the coolant route was going to happen. Now, in a normal Miata, which is naturally aspirated, what the decisions that they made mean that really not that much changes. Everything works fine, and your Miata will not overheat during normal operation, even in very hot ambient conditions, like you're out in the desert, or just the temperature is very high in general, and you're running the car on a long road trip or whatever. It's still not going to overheat. At the back of the engine, you're sort of limited in flow to a much smaller hose that goes to the heater core. And in a Miata, many people feel like that the heater core, which runs, your heater and everything, is actually an extra piece of the cooling system, which is not normally the case in a car. It's sort of an add-on that you use to heat the cabin, but it's not really a critical part of the cooling system. And so it provides an extra little radiator almost or heat sink for the coolant flow out of the back, and it sort of helps with the temperatures for cylinder 4. So in the diagram, you can see the coolest part of the coolant is at the lower radiator feed, which comes in from the driver's side, and it enters what's called the mixing manifold, or the water pump inlet. And it's basically a pipe, but it has a number of things kind of coming into it, going out of it. And so this pipe connects to the water pump, which is the highest pressure part of the system. And so the water pump's going to draw that in, pump it through and around the block, but it's also going to mostly kind of pump it upwards, where it comes out the water neck at the front, and then it goes directly back into the radiator without having spent that much time in the actual block where it needs to be. And so the upper radiator hose comes across at the top, and then the coolant goes through the radiator. As it cools, it goes downwards, it gets pulled in by the pump, and the process repeats. Now, as the coolant goes across the block, there is a little bit of flow out of the back from two areas. If you're running a later in a model, a 94 and above, then you will have a small hose on the passenger side, which goes around and first connects to what's called an oil cooler
It's actually not an oil cooler. It's more like an oil warmer, and it helps the oil to heat up faster when the oil is less hot than the coolant. And so it's a very small little kind of coolant block or something that is right next to the or kind of right with the oil filter on the passenger side there. Then the line continues up and connects to the throttle body, and it provides some sort of de-icing capabilities for the throttle body in general, so there's no sticking, and that the idle air control valve can work correctly and get a little bit of warmth, in a cold environment. Also, not considered terribly critical. And then from there, it comes back around and connects to the water neck that's on the front of the block. Now, the water neck also has an outlet that goes downwards to the mixing manifold. So there's a continuous like cycle that goes around there, and this is managed by the fact that it's much smaller hoses. So that means that not that much coolant is going to actually be going downwards back into the mixing manifold from the water neck. That most of it will go through will be going through the main upper radiator hose. Now, from the back of the block, we do have one semi-decent, size hose. It's like the middle size hose. It's about 5/8 size hose, and it goes into feeds from the back of the block to the heater core, and then the heater core exits and goes through a hard line which passes under the exhaust manifold and back into the mixing manifold. And so that's the entire route of the regular OEM Miata engine, and that's true all the way from 1990 through 2005. It's basically that same process. Okay, so in a reroute, what we're doing is we're going to be changing where the upper radiator hose comes from. We're going to take it from the back of the block instead of the front, and we're going to block off that front water neck. So once you've blocked out the front water neck, then the water has nowhere to go but out and towards the back. And so from there, it will pipe around, usually on the outside of the intake manifold on the passenger side, and back around and into the top of the radiator where the upper radiator hose normally connects. Now, as I mentioned, it's the front water neck that contains the thermostat. And the thermostat is there to help the engine reach operating temperature quickly. And then at a certain temperature, which is the operating temperature of the vehicle, it opens and allows it to cool. So an ideal coolant and cooling system will basically cause the engine to warm up to operating temperature, which in a Miata is about 190 degrees Fahrenheit, instantly, and then open, and then keep it there forever. That's an ideal cooling system. The thermostat does not, keep it cool from the perspective of overall operating temperature. It just simply increases basically the volume of coolant that's accessible to be, to grab the heat out of the engine. And so that's its purpose. Once it opens, it allows extra flow of all the additional coolant into the block and to circulate more. By keeping it closed, it causes the coolant that's in the block already to heat up quickly, and then therefore the oil temperature, more importantly, to heat up quickly. Now, the thermostat needs to be able to be in contact with the hottest part of the coolant. And so now, since we're taking the hottest part of the coolant from the back of the block, we will want to put the thermostat in the back as well. And so various reroute kits exist to deal with this situation, to make it so that either A, it's easier to get to, or B, it just allows you to put it there. Now, the path that I'm going to take is a little bit different and doesn't involve a kit. So this is where I want your feedback. Tell me what you think of how I'm going to do this. So let's get into that. So this method was popularized first by Miata Mike, the Miata King. He's one of the OGs of YouTube Miata communities, and you should really check out his videos on this so you can see it for yourself. He does this for his customers' cars in his shop, and he mostly does it on NBs because of the way it requires less modification, but it is possible to do it pretty much on any Miata. So what's involved is you take the front water neck, and this part that comes off is what's concealing the thermostat, which is inside. You can take this and move it around to the back. There's an identically shaped, at least from this perspective, sized housing like this on the back of the block. And so this will actually bolt right in to the back of the block. There is also a space in the back of the block, because remember, this is how this engine was originally designed, for the thermostat. So this exact thermostat will fit in the back. And we're going to screw that down, and you can even, in his mode, you can move the back housing to the front, and then you would pipe that in the same way using the proper hose to the back hose that leads into the heater core. Now in my case, I'm going to be doing something a bit different. So for my heater core, instead, I'm going to be feeding that from the water line here from the turbo. So I've got my heater core line hooked up to this AN line, which is going to route around here, and it actually it'll bolt down right there, and it'll come in there, so you can see it goes straight in. And I'm actually even reversing the flow, and the reason for that is to just provide a little bit more space here for the downpipe. And so the other side of the heater core is going to be connected using the original hose to the hard line that goes underneath the manifold and comes across right down there. Now, as I mentioned before, the feed to this is the originally unused, down in the depths, port for the turbo that this engine was originally built for. So unused in the Miata. It was used in the 323 that this engine was used, had a turbo in, and we can use it again. It's just simply blocked off, and I plugged in an AN fitting, and we're now feeding the turbo from it. So that is pretty cool coolant coming from that feed line, going through the turbo, getting warmed up, going into the heater core. This is not nearly the flow that it probably was, because of the size of the lines are substantially smaller. 6AN is a fair amount smaller than the 5/8 style or half-inch style hose that this guy is. So it's going to be reduced flow to the heater core. But honestly, for me, in my situation, I'm in the South, and my heater is sort of rarely used. Okay, so we're swapping this around. Now, as part of the fitting on the back, the temperature sensor is going into this housing on the back, and you can't really get a good shot of it, so I'm not going to try. But once it's apart, we'll see it. But the temperature sensor also has a port that's unused, that's blocked off with a bolt, that we can screw it into. So it should fit just right into that port, which is actually before the thermostat, which is where you want it. And the thermostat goes in, and then this neck will come out. And then what we will have is some hoses that come around. Let's see what that looks like. So for hoses, originally I was trying to use this hose, which is used on a lot of different reroutes. It's a single hose solution that works with the spacer type of style. And unfortunately, this doesn't quite work because of the, if you're reusing the housing at the front, normally that type of reroute uses a Kia water housing, which is the same size, but it sticks out more horizontally like this. It comes out like that so that this attaches on quite well, and then it routes around the engine, and then it comes up, and you can have one hose. In a 94, 95, because of the way the throttle body is and all this stuff with the intake hosing, you need to have something a little bit more like this hose, which is a 22382. But anything that basically makes kind of a Z type looking pattern will fit. But yeah, this with my super cheap reroute where I'm reusing pieces of the car, this hose was not going to work. So instead, we went with the original Miata Mike hose, something that he does normally on MBs, but it will work on an NA, as I mentioned before, if you do some things to the coil pack. If you're replacing the coil pack with coil and plug, this works perfectly. So what I've done is I've unbolted a couple things just to make clearance a little bit easier. There's a grounding plug right there. Normally your EGR stuff would be right here. If you're going turbo and you have mega squirt, you don't need any of that, so that can be removed actually. And this routes right under the line for the brake booster, and it comes in right here. You can see the neck from the front is now placed on the back, and it basically points up and a little bit to the passenger side, but there's plenty of clearance to get that on there, and this will route just nicely underneath this hose, as I mentioned, and underneath these wiring harnesses. And then it'll kind of come around, and then we've got a pipe. This is a 1 1/4 inch pipe, because all these are 1 1/4 inch hoses, and this is going to connect to our little Z hose, which is going to fit in just like this. So we're going to trim this, somewhere in here so that the pipe can be more of the distance. I think it just looks cleaner not to have the big giant hose. Actually, with the pipe here, it just looks a little nicer. So we're going to have, a clamp here, a clamp up here at the end of the pipe, because that goes to about all the way to there, and then a clamp on the radiator. All right, so got the thermostat housing off, and the back is basically the same. It has a stud at the bottom and a bolt at the top, and you can take this and we rotate it around, and we can place our thermostat where it was right here instead in the back. So let's take a look at that. All right, so coming around to the back, I've already got the back housing off and the new housing on, and this is a little bit interesting to get to because normally where that bolt is, right in here, that bolt, the temperature sensor is coming out right there, and so it's kind of blocked a little bit, but you can get like a shallow socket on there and get it out. I have a flex head socket driver in a 1/4 inch, and that allowed me to get in. You can also, once you get that hose out, you can come in from the other side and work on it like that. And then this one, the nut that's on the bottom, is actually pretty straightforward because it's fairly easily accessible. Again, with the coil pack out, everything, this is the coil plug right there, just laying there, and you can get to everything. Now, beneath here is where right there is the temperature sensor. This is going into a factory port on the back of the head, and it's meant to do this. In the 323 version of the BP engine, this port is used exactly this way for the temperature sensor. It plugs in right there, and it will thread in perfectly. So once the temperature sensor is in there, you can see that the neck is clearing it. There's no problems there. With the original reroute, you had to put a spacer in here, which was very prone to leakage eventually, because now you have twice as many gaskets as you would normally. And I don't know, I think this is a better solution. It's a little bit cleaner, it's a little bit more OEM, and so you don't even have to lengthen your temperature sensor wires. This plug is going to plug in there. It basically went from that side to right there. So there's no
lengthening required. Once you've got that, you can put your hose on, and you can put everything back together. Now, of course, you want to clean off that gasket very well back there. And let's take a look at the thing here. Okay, so then we have this guy. So our thermostat normally has this weep hole up at the top, and it has a little jiggle pin, which allows air to bleed out of the system, but not let too much coolant flow out. And what I've decided to do is to go ahead and remove this pin just to give a little bit more flow past the thermostat, because with this housing we no longer have the, if you look at the old housing, we no longer have this line right here, which is about a 5/8 line out, that gives continuous flow through the back of the head. Now, with the reroute, that's sort of less needed, continuous flow, because the number 4 cylinder doesn't need the extra cooling, but you do want enough flow to go past the thermostat. So the new housing is going to sit on here like this with the new hose pointed upwards, and there needs to be a little bit of flow past that. Now, there is on the back of the engine before the thermostat a line that comes out of here, and it goes around the block underneath the intake manifold and to a little oil cooler, warmer, whatever Mazda had in mind, here underneath where the oil filter is. So it goes into there, comes back around, comes into the throttle body, goes back around, and then eventually is this line, which goes to this neck again, and then back down to where the water pump is. So there is some flow, but we potentially want to make that a little bit more flow. And the 323 Mazda that I mentioned, they have what they call a bypass pipe, which is about this size, maybe a tad smaller. And the bypass pipe in that situation is bigger than the basically 1/8 hose that you have, the smaller hoses that you have in the Miata. So we want to make that be kind of similar, and so that way the flow will work correctly. So I think by just simply, some people drill extra holes in here, but at that point you're starting to get to where your thermostat is not going to work correctly. All right, looking not bad. So we got this back here, waited the hour or so, torqued it down, the housing down, got this installed. So this hose is looking good. It runs through, actually has clearance from the intake manifold, which gets kind of hot, but just in case, it's got that little plastic thing, which also protects it from rubbing against the wiring harness there. Comes across, reusing some of the clamps, comes across and into the radiator. This is pretty tight. I don't think there's going to be a ton of rubbing. I wish it was maybe a little bit tighter, but you know, we'll see how that goes. This little length of hose can be replaced pretty easily, so we'll just see what's necessary. And you can see this little guy down there, that little green plug, it's right up against, to prevent rubbing, what I've done is it's right at the level of that clamp, so that if it rubs, it's going to hit just the smoothness of the clamp, so it's not going to affect the wiring or the hose. Looks good. So the last part is, of course, we need to make a plate for this. Ideally, you would just take this all off, and you can run a single hose that goes all the way across to here if you want to keep your various small hoses, you know, that goes to the oil cooler and the throttle body and stuff like that, especially if you're in a cold climate part of the year or whatever. You may want that. So you can just run a small hose all the way around and down, and that's fine. You can take this whole neck off and put a plate over here. But for what I'm going to do is I'm just going to make a plate for just this part and screw it back on with the same nut and bolt that came off of it. So this is about 3 inches. So you need a piece of plate metal about 3 inches square. That should do it. And you can cut it to sort of match, maybe make an oval or something. So we'll get that done. So we got that plate painted up nicely. I primed it with some high heat primer and some high heat paint, the same stuff as I used on the valve cover, and just screwed it on. I didn't use the regular gasket because I couldn't get one locally, and I just decided to use some of this RTV gasket maker. I figured that would be good enough, and it will be obvious if there's any leaks from there. So I just decided to go with that to begin with. Alright, so that's going to do it with our DIY coolant reroute with no kits, following in the theme of this video series. Hope you learned something, and I would like your comments below. So let me know if you think this is a good idea, if it seems bad, it seems like not enough flow, something like that. I'm going to run it for a while just to try it, but I would welcome your insight. So thanks again for watching. We're going to hit the next video with the exhaust and downpipe build, and that's going to basically complete it. We'll be able to start the car, so very excited for that. It's been a little bit delayed because of miscellaneous family stuff. We had the Easter weekend, I got sick, so it's been a little bit delayed, so I apologize for how long it's taken to get this episode out, but it's out now, and I'm starting the exhaust stuff right now. So thanks again. If you enjoyed this, give me a like, and don't forget to subscribe to see more in this series. Thanks a lot, everybody. Catch you on the next one.